cool. So let's begin talking about records. So what are records? First of all, let's have another look at types really, really fast, right? So where is it? Like 2 lessons ago, right? We talked about types, and we said that, let's see, did I explain the differences between data and type? Not really. I think I've gone over it once, but I'll go over it again. But like, you remember what a product is, right?
Yeah.
Okay, cool. Hello, Divine Messiah. Welcome. Okay, so let's write code. Okay, so let's do a new file, module part 4, where, and let's start typing, right? So, okay. What should I explain first? So we saw how we can create new types using the data keyword, right? Right, so we did something like data point equals point int, right?
Yeah.
But then this isn't really very easy to use, right? So for example, what if we have a like 3D point, right? We have 3 ints, and then which one is okay, so let's do this direct, right? So this is a 3D point, right? In 3 dimensions. Which one is Y? And you could say, okay, it's the second one, right? But like, how do you really know that, right? It's like it's by convention, sort of, right? So a good solution for this is records, right? So alternatively, what we could do is we could use type and say type point equals to, then we could say x is int, and then y is int, and then z is also an int.
Okay.
And this is kind of like, so if you think about it, because I know you've done some C#, right? You can kind of think of it as a structure in C#, where this is a type and these are attributes for the type, sort of, right? So let's see, how do we do something with point, right? So creating a new point, right?
Yeah.
So how do we do it? Well, we just do make origin for, well, let's just define origin, right? Origin, right? Which is a point, and then we can say origin is x is 0, y is 0, and z is 0. And that's it. This is how we define a point. We need to import prelude, I think. So we have integers in scope. What's the problem here? Convert the existing. Oh, okay, yeah. Let's comment this out, right? Because right, you can have 2 things with the same name. Okay, so you will notice here that we're not using any constructor name, right? We're just doing this. Also important to note is that origin prime, you could also define it as x int, y int, and z int directly here in the type. And they're exactly the same, right? So this is kind of, so when you define this, so let me type it here. So types are well, as the types are really just aliases for convenience. They do not well, let's just do that, right? Convenience. Right, so we could just type this everywhere instead of point, but like this is way too long, right? So we'll just use point, but we don't need this, right? We can just use the regular thing. Okay. So let's see. Okay, so this is how we create things, right? So let's say the point type is just an alias. We could just use the expanded version as well, right? It is the same thing. Okay, so how do we get x, right? So we could say from point I want to get an int, right, which is the x coordinate. So get x, we can say for some point x is p dot x, right? It's exactly how you expect it to be.
Yeah.
Right? It's just that simple. And then of course I'm pretty sure you get you know how to get y and z, right? It's just the same thing. We could do like okay, increment everything, so all coordinates by 1. So how do we do that? So let's say from point we go to point, right?
Yeah.
Okay, and then we can say for some point p, for example. So this is one way to do it, right? And maybe we'll do several ways to let's say several versions of this function. So we could say something like x is p dot x plus 1, y is p dot y plus 1, and then z is p dot z plus 1. Oh, sorry, I'm mistyping here. And this is a simple way to do it. It works and so on, right? We could do increment prime also from point to point, which we could say something like this, x, y, and z. So this is sort of a pattern match for records, right? So this basically, instead of typing p and then doing p plus x, dot x everywhere, right? We could just do this. And then we could say x is x plus 1, y is y plus 1, and z is z plus 1.
Yeah.
I think this works. Right, and it's kind of the same, but then you don't have to do p plus, right? You can pattern match here with any of these or all of them.
Yeah.
And I think there's one more thing you could do, which is a bit mind-blowing, and I actually didn't know this for the longest time. I actually don't even think this worked until recently. I think you can do p plus 1. You can't? I'm almost sure you could do that. Weren't there instances for... Oh no, so I think you need to do x1, y1, and z1. I think this will work. Yeah, there you go.
Okay.
Which is pretty cool. The idea being that like you can have an like if you like, okay, how should I explain this? So this has integers, right? Everywhere.
Yeah.
Right? So if you're trying to add p with something that's also a point, right? And there's this operation, the addition works on like 1 and like the integers, then it will just do x plus x, y plus y, and z plus z, right? From left to right, right?
Yeah.
So for example, I think if this is missing, so I think if z is missing, I don't even remember what it does. Does it just... Yeah, it doesn't work, right? So you just need everything, right? You can say, okay, so it needs to be the same. And I think if you have something extra, like something like this, I think it will also not work, right? So they need to be the exact same type for this to work, right? Mm-hmm. Okay, cool.
Question is,
yeah.
If I like this incremented by 2, right?
Mm-hmm, yeah.
Just so I'm sure it makes... Yeah. Okay, I understood. Okay, yeah, go.
And it works with like a lot of operations. For example, this could be multiplication. We could multiply everything by 2, right? And it could be some sort of scaling or something like that, right?
Yeah.
Okay, cool. So yeah, that's it. Now you know records.
Okay.
I mean, okay, this is the basic idea, right? So then there are a lot of cool things that we could do with it, right? For example, so I'm not even sure. So I'll tell you some things that are a bit more advanced, and we'll get back to them later, but I just want to introduce them now.
Okay.
Actually, maybe before we do that, let me show you, let me think. Does that make sense? Can we redo any of the things that we've done before using records to make things better?
Would it work on the employee and stuff?
Yeah, sure. But I was thinking something more fun.
Yeah.
Like for example, 3, right? We could redefine 3. So let me paste the old 3
as
here.
a type.
Right. So instead of this 3 here, so what's one problem here? Like these things, it's kind of like, okay, this is like, we know this is left and we know this is right.
Yeah.
Right? But it's only because we say so, right?
Yeah. Okay.
Right, so we could also say, okay, so node is a record where left is this, and then value is this, and then right is this. Does it make sense? And then we can write a function for trees, like which function? Let's just copy one function and implement it here. Like let's do find what? No, not find. Let's do map, right? So I'm copying it. Let me paste it here. Right, so it's the same thing except node here. We could just say node n, for example, right?
Yeah.
And we could say here n dot value here, and then n dot left, and then n dot right here. And it should work just the same. What did I do wrong? Let's see. Could not match. Oh, right. Okay. So the problem here is that we need to say like left is this, and then maybe let's make this easier to read. So let's do something like this. Okay, and then let's say the value is this, and then we don't even need parentheses anymore. And then right is this. Okay, and I think now it's correct. Yeah, there we go. Right, and now everything's good. Right, so this kind of makes it a bit easier to read, right? Than just having to remember like, okay, this goes to the left and this goes to the right and this goes to the middle, right? Because at some point I think you wrote like fx here, right? And like, okay, it's just because I defined the you wrote something like node fx and then left and right or something like that, right? And I mean, like, why wouldn't this be correct, right? Just because I decided that left is it's left value and right other than the other way around. It's and one more thing, like here you can put them in any order you want.
Yeah.
Like in this thing, it doesn't matter. Okay. So this is another example, and then of course like we did the like in where was it? I think it was in part 2, like with the employee homework or something like that.
Yeah.
Don't even remember
Yeah,
where
it's
we.
part 2.
But I think like where did we write it?
But I think it was the homework of part 2.
Yeah, I'm looking for where we pasted it, but I'm not sure where we did that. Maybe we pasted it at the beginning of part 3 or. Like in which file? Oh, homework 2. Okay, I found the file. Yeah, and here, let's see, did we have any, like for example, the manager type, like constructor here, right? We had two booleans and we kept confusing one with the other, right? But if we used a record here, then it would be a lot easier to know which boolean means what, right?
Yeah, makes sense.
Okay, let's not rewrite that because, it doesn't really help us much now, but that's the main idea, right? We could do this for any other types as well. Okay, so let's see, what other things can we do with this? Well, okay, so let's write a few more types, right? So let's see, point to d equals to x and int and then y int, right?
Yeah.
And then type point 3d and then sets of type int, right?
Yep.
So let's say I want a function, some like get x prime, right?
Yeah.
Because we already have a get x, that's the only reason. But I kind of want to get an int, so I want to be able to type something here, right? And I want to get the x coordinate, but I want to get it from any point. Like I want it to work on both of these, right? Because it should work on both of these.
Yeah.
Do you agree?
Yeah.
Because both of them have an x. But what's and the implementation would be get x p equals with p dot x, right?
Yeah.
And this will work in both cases, right? So we know how to write the implementation. One thing we don't know is how to write this type.
Yeah.
Right? So I think actually that if we do this, Purescript will tell us what this is. If we put an underscore here. And it does. But let me explain it to you. But this is a good trick to remember, right? So if you know how to write the implementation, right? But you're not sure what the type looks like, you can even delete it, like you can even have it like this, right? And if you open the, let me see what's it called. What's the window name called?
It's the one with the light bulb, yeah? It's called fixes, or what are you talking about?
Yeah, but I'm trying to see where I can open it. In this
I
thing.
just hover over get x prime.
Okay, I found it.
When...
There we go.
Oh, okay.
And then somewhere it says wildcard type definition inferred type is x of type t0, t1 goes to t0, which is not very easy to understand, right?
Yeah.
But if we do something like goes to int, then I think it changes to, and it tells us that it has to be x, like, so let's see, it says something like this, x int or t0 is what it tells us it should be, right? And then we get an error saying that t0 is undefined. So to fix that, we need to say for all t0. And I'll explain this in a second. And now it will work. So, okay, let's rename t0 with a, or just let's say r.
Okay.
And let me try to explain this, because this actually introduces two things, right? First of all, this is, I'm introducing type variables for the first time. And yeah, so, okay, this is a type variable. You add it with using this keyword for all and then giving it a name, right? You can use any name here. You could use the name T. I just used R, right? But it can be any name as long as it's lowercase, right? You can also type rest. And it's fine. You can type words, but like the first letter needs to be lowercase. Okay?
Okay.
And then you add a dot. Okay?
Yeah.
And then you add your normal type after the dot. So that's the syntax, right? So let's see. Type let's do this thing. Type variables. So they allow us to abstract over types. And I'll explain this a bit later in a second. Syntax is function name for all x or a or r, and then we can use r here, right?
Yeah.
In this thing, right?
Yeah.
So what does this mean? So this basically means that whoever calls get x, right, can decide that rest can be anything they want. Right? So me as the user of this function can say, okay, I want rest to be whatever I want, right? It doesn't matter. It can be literally anything, right?
Yeah.
So I'm saying, okay, this function works for any rest, right? Any variable of type rest.
Yeah.
And I want it to, like, I want to get, like, my input needs to be a record, right? This is what the syntax means, right? A record where it has an x of type int here, right? Integer. And then this means anything else.
Okay, that's what I wanted to ask you. What does the second, because it makes sense until the second rest. Okay, so the rest is actually, so it's anything else.
Yeah, so this basically means I can add anything to that, right? So for example, so let's use it, right? So I could say, let's write some examples here. So you could say get, so let's do get 1, get 2, get 3, whatever, right? So get 1 is an int, get 1, I can call it get x prime with x value 0, right? So what does this mean? This means that rest, in this case, gets replaced with nothing, right? I want rest to be nothing, right? Okay, then get 2 int, so let's see, in this case, rest is nothing. Let's just type it like so, right? And then let's do get 2 equals to get x with x equals to 0 and y equals to 1, whatever, right? So in this case, what do you think rest is?
I mean, in my head, it should be the 1.
Well, it's y, right? It's the type, right? So it's y of type int.
Yeah.
Right? And then get 3 of int, get 3, we could call get x with x is 0, sorry, x is 0, y is 1, and z is 2, or whatever, right? So in this case, what do you think?
It's the y and the z.
Yep, and we usually type them as like in parentheses, right? So kind of like y int z, int z int, kind of like so, right? But that's the idea. And then you could even say, for example, wait, and I mistyped here. It should be like so, and then it's get this get x, right? Get x. Okay, so it's x0, and then we could say blah equals to foo. Right, so it doesn't matter. It could literally be anything, right? So, right? We could add whatever we want here. As long as we have an x of type int somewhere here, that's fine, right? And it could even be like right, and this also works totally fine, right? And like it doesn't have to be like in a certain position. It can be anywhere as long as it's there somewhere, right? And this is super cool, right? Because it allows us to write very generic functions, right?
Yeah.
Because this works over any sort of record which has an x of type int, right? But for example, we can work on every record which has an identifier somewhere or whatever, a name, or right? We could get the name for any record or something like that, which is super cool. Okay, and we'll definitely talk a lot more about type variables pretty soon, right? But this is just the like first introduction to type variables. Okay, so I think so. We've been at it for 1 hour. Let's see. Type classes will not take us very long, I don't think. So I think let's have you write a few, like, just so you get the hang of it for a little bit. A few things with like a few functions. Okay, so let's see, what kind of functions should we write? So let's define a type here, right? So let's say type person has a name of type string, an age of type int, and let's just do that for now, right? Okay, so can you write a function that gives like gets the name from a person? Let's start with something easy.
Okay, so we have to go for the get name.
Sure.
And I have to use the for all.
Only if you want to. It's going to be harder.
I mean, I don't have to because I don't have more types of person.
No, I mean, okay, so you do this if I'd asked you to get the name from any record that has name, right?
Yeah.
But what I ask is just go from person to like get the name from a person, literally, right? So it doesn't have to be polymorphic, is what it's called when you use for alls.
Yeah. So I give it a person.
Yeah.
And it returns a string.
Yep, correct.
And now we get name. So get name should be. I keep thinking of the make person.
No, it's no longer like that, right? You don't do like the only way you could do pattern matching is you can also do pattern matching, but just do the simple thing.
Name equals. Is it like this?
Well, no, because like when you do okay, so first off, there is nothing in the like you can write person here because it's a type alias, but you can never write person here because it's not a constructor.
Yeah, I did the same mistake last time as well.
So you can't do this. The thing is, so is this a name? So what's here? What's the type of this?
This is
of our input.
It's a string, but so it's not a person.
Wait, is our input a string?
I mean, that's what I declared for it to be a person, but I'm giving it name, which is a string, right? So it's not.
Well, if you declare it as a person, then this is a person, right? It doesn't matter what you type here, but the input is still a person.
Yeah, okay. Yeah. So
I mean, I think you're getting stuck on something that's okay. Okay. And then how do you get the name out of a person? Like again, it's like, yeah, exactly, right? Cool.
Yeah.
Okay, excellent. And again, like you could just do P or whatever you want. That's fine. It doesn't matter how you name it, right? P1 will do just fine. Okay. So let's say I have. Okay. Okay. Can you quickly also do the get age? That should be very similar.
Yeah.
Okay.
Get age, where I get from a person, and it's an int. Where get age of let's say person is equal to
Okay, cool. So now can you write a function that goes from so let me type in words what I want from you, right? And then you can try to implement it, right? So I want a function that given I want function print, that's called print, right?
okay.
Which I want to use as print name Vlad and then age 36, right?
Yeah.
And I want the result of it to be Vlad has 36 years, or rather is 36 years old.
Okay.
And well, I want this as a string, right?
Mm-hmm.
So is this enough information for you to implement it?
Maybe.
Yeah. Try it.
There's only one way to find out. So I again I take the person. So let's say this is the print, and I give it a person, and it returns a string to me.
Yeah, that's good.
Okay, so let's see. So I want to print the name and the age.
Well, you're still only taking a person as input, not more than one
yeah,
thing.
yeah, I'm lost in translation.
There you go. That's good.
Okay. Okay.
Yeah, that's good. Well, do you remember how you concatenate strings?
Yeah, it's wait.
Yep, that's the correct thing.
Okay.
Okay.
And now I have to add
yeah.
Like that.
Sort of. You're forgetting, like, for example, and this you'd probably okay. It's fine. There's one problem here. Let's see if we save. Let's see, why is it showing it here? That's super weird that it's showing the error there. Yeah. Okay. Well, it's saying that this is could not match string with int, but then it's wrong because I'll tell you the error is on this part that I highlighted. Can you guess why, or do I tell you and then you fix it?
Okay. Just 1 second. Okay. So for some reason, okay. Well, it sees so p1.age is int, and I'm saying that my output is a string, but it can't also have an int.
Yep.
So I have to. Was it like this?
Yep, that's correct. You don't even need to parenthesize. You don't need them. Yep, that's just correct. I think it should compile now. Yep, it does. Okay, so let's try running it because there's still one small thing that doesn't really matter as far as I'm concerned. But let's see, are we in the right place? Yes, Spago REPL is what we need to do here. I need to import part 4, and then we could do print. Let's see if it knows print. Yeah, it knows. So we can do print where we give name Vlad. Let's just use the same example, right? Age 36. Right. So do you see the problem?
Yeah.
Can you? Do you see it? Do you see it on my screen, right? Or?
Yeah. It's I don't have spaces. And of course I don't have why did I do this?
yeah, exactly.
Yeah,
You don't need that.
yeah.
And you also needed the space here after is, right? Because otherwise,
I put it before years. Or oh no 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 no. Yeah yeah. I
you need
just
both, right?
realized I did
Yeah,
put
there you
yeah.
go. Let's see. So now if we save it, and then we reload and run it again, it should be right. Yep, there we go.
Mhm.
Cool. Okay. So let's see. Wait, how do I make this? No, not this. Is there? Okay, let's just close it. Okay, so we've got this down. We used records a bit. Okay, let's go to type classes, and then maybe we'll come back afterwards, right? So really, there's not that much to records, right? They're a very simple feature. For Purescript, but it's very very powerful, and we'll learn later ways to use it. But this is one of the things. If you're also trying to learn Haskell at the same time, Haskell has something that's also called records, but they're way less powerful than Purescripts. And way less nicer to use because you don't have this syntax. You can do p.name in Haskell, and it's a lot more annoying to use without it. And well, there's a few other differences, but that's the first one that gets beginners. Okay, so let's do type class.